Hi everyone, today we're going to look at some of the review questions from the review guide I sent you for the third exam for Math 209. So let's share the screen on that review guide that I sent you yesterday. So basically, in red you see the actual problem worked out, or how I worked it out. Okay. And so this first one, in a 2009 study of 950 Grand Valley State University undergraduates, the question, do you think birth control pills prevent STDs, was asked. 242 think falsely that birth control pills can prevent STDs. And it says clearly falsely because it can't. Okay, at a 0.05 significance level, can you support the claim that more than 25% of GVSU students falsely believe birth control pills can prevent STDs? Now, in reality, this really did happen. This was a study that was taken in 2009. And out of the 950 people they asked, 950 undergraduate students at Grand Valley State, 242 did think that, which, whether or not that's greater than 25%, is still pretty disturbing. So our first thing is to figure out H0 and HA. So H0 says P is less than or equal to 0.25 because the claim is that it's more than 0.25. So HA is the claim. Our level of significance in part 2 is 0.05. Our test stat, so anytime you have to calculate a test stat or a p-value, use your calculator. Put all this stuff into the calculator like we talked about earlier and come up with that p-value and or test statistic. And I repeat that 3 and 4 from the calculator. So we get a test stat of 0.34 and a p-value of 0.3680. Using one prop, that should be, using a one prop z-test. So for 5, we get 0.3680 is greater than 0.05. So the p-value is greater than the level of significance. That means we're going to fail to reject H0. Now think about what H0 was. H0 was the opposite of the claim. So if we fail to reject it, that means we cannot support the claim that more than 25% of GVSU students falsely believe that birth control pills can prevent STDs. We're going to build a 90% confidence interval. The 90% confidence interval can be generated with the calculator as well under one prop z interval. Stat, arrow over to test, and select A. Enter based on the information from 1, fill in with x equal 242, n equal 950, and the C level is 0.90. You get 0.2315 to 0.278. Find the error. Remember the error. So anytime you have somebody who wants you to find the error, you're given an interval in this format. Anytime you take the maximum value minus the minimum value divided by 2, whether it's a one prop z or a t-test, or I'm sorry, a t-interval or a z-interval. So the error is always plus and minus, so it's plus and minus 0.02325. What does this mean? We should always know what it means. So there's a 90% chance that the actual percentage of GVSU students who falsely believe or think that birth control pills can prevent STDs is between 23.15% and 27.8%. Kind of disturbing. Another question. Retail purchaser from Macy's wants to test the claim that the mean shoe size for US females is size 7.5. She knows the population standard deviation is 1.6. To test this claim, she randomly selects 250 customers and finds the mean is 7.8. At a significance level of 0.1, is there enough evidence to support the claim that the mean US female shoe size is 7.5? So first off, since we know the population standard deviation of 1.6, we can use the z-test. So H0, since it says the shoe size is 7.5, we can say mu equals 7.5. That's the claim. The opposite of that then would be not equal to 7.5, so that'd be HA. Our level of significance is 0.1. Calculating the test stat and the p-value, again, generated with the calculator. 2.96, and the p-value is 0.0030. So for 5, we're comparing the p-value again with the level of significance, see how it compares. Since the p-value is smaller than the level of significance, we are going to reject H0. Since the claim was H0, that means we cannot support the claim that the mean shoe size was 7.5. And again, calculating the confidence interval. For the 90% confidence interval, we use a z-interval and get 7.6336 to 7.9664. For the error, same idea as above. Max minus min divided by 2. And that gives us plus and minus 0.1664. What does this all mean? This means there's a 90% chance that the actual adult female shoe size in the US is between about 7.6, and I just rounded to the nearest decimal point, and 8.0. For 5 is just some information you should know. These are the z-score values for confidence intervals for the 80, 90, 95, 98, and 99% confidence interval. Keep those handy, you might need them. In 6, we have the following. The BMI, body mass index for supermodels for Victoria's Secret brand, has been dropping since the 1980s. A safe BMI for an adult female is anything above 18. A medical researcher decides to test the claim that the BMI, the mean BMI, for recent Victoria's Secret supermodels is less than 18. To do this, he collects the following data for supermodels from the Victoria's Secret brand, and it lists the data. So when we have a list of data like this, there's no calculation of a standard deviation or a sample mean. We put the data into list 1 after we clear it. Once the data is in list 1, we arrow over to tests and select t-tests in this case. We highlight data instead of stat. We highlight data because we have to use list. And we select, make sure list 1 is selected in the prompts. Then we fill the prompts in the appropriate way. It'll ask us what mu0 is. We put 18 in this case because that's a hypothesized mean. And then it'll ask us the list. It'll be L1. And then that one line where we put in the symbol and the alternative hypothesis. So in this case, we'd highlight greater than. And we get the following. It tells us that, it's got a little typo here, I see. It tells us that the t-score is minus 0.55 and the p-value is 0.7027. 0.7027 is greater than 0.05. So since the p-value is greater than the level of significance, we have to fail to reject A0. Since HA is the claim and we fail to reject A0, we cannot support the claim that the mean BMI is less than 18. And then again, constructing the confidence interval, put the data into list 1, and then follow the t-interval with L1 as your list, and a C level in this case of 0.98. And we get 0.1656 to 18.957. Take our max minus min, divide by 2. That gives us our error. We end up with plus and minus 1.1985. What does this mean? There's a 98% chance that the actual mean BMI for Victoria's Secret supermodels is anywhere between about 16.6 and 19, rounded 1 decimal place. There may also be a question about how you can find what the sample size is. Remember, the sample size, if we're dealing with means, is n equals the z-score based on the level of confidence. So 95% confidence would be that 1.96 that we saw in the table above, times the standard deviation of the population divided by the error tolerance that they want. And that whole thing is squared. So how big of a sample will we need for a 95% confidence interval? We know the population standard deviation is 3.95. We want it to be within 0.8 units rather of the actual mean. So we put that information in. This within part is the error. So that goes in the denominator. The 95% confidence interval tells us what our z-score is, and we're told the population standard deviation. When we put this into the formula and calculate, we get 93.654. We always round that number up to the nearest whole number. Always round it up. So if that was 93.1, I'd still round it up to 94. Hopefully this helps. We need to get our test done.